Having fun.
Having fun.
Yeah, I like to torture
Torture
with fun.
So this lesson we're gonna have like some evaluation of words. Torture became fun. So dope became
I can literally
amazing.
hear his
Black
music.
became white.
Hey?
I can literally hear his music.
Really?
Yeah.
If I
I mean, I thought it's only color.
Can you turn your music off?
You can hear until here.
Yes,
Yeah.
yes.
I can't, but thank you.
Oh.
Yeah, I'm turning them.
So, Benny the Bear,
What's up?
who is very anti-torture,
What's called niggas about it.
So he doesn't
gives
like
Lowry the bum of disrespect. How do we find his centre of gravity?
By throwing him, by dropping him down.
By dropping him.
Like,
Yeah, I guess.
No, not in that way.
Otherwise, by seeing on what.
Sorry about this, it's in the interest of science. Oh, he's terrified, he's terrified, he's terrified. Right.
I guess it's.
Hey, I'm waiting for his centre of gravity to emerge.
It's his leg.
It's his leg. How do I get his centre of gravity? Yes.
Is it the part that hits the ground first when it's being dropped?
No.
No. What is the centre of?
It's the part which
The part where
Pulls it down.
if you hold it on your finger, balance.
Okay, if you hold it on your finger, it's the point at which there is balance. Okay, so for a ruler,
it's in the middle.
it's in the middle,
Somewhere in the middle.
somewhere in the middle. So it's slightly, I have to move it over here slightly. Okay, yeah. So the centre of gravity, or centre of mass, same thing, is somewhere along that line, yeah? Happy with that? It's a balance point.
Yeah, just try again. And try again. No, it almost works.
He has no.
He has none. No, he has a centre of gravity.
His head. I guess.
This is a nice, symmetrical, rigid object.
He's not symmetrical.
He's
Oh,
perfect
really?
anyway.
No, you're being nice to him. You're trying to make friends.
Yeah.
This is
Oh, the give up procedure actually works.
This is
Oh.
Wally's way of making friends.
Yeah, he's gonna later. Okay, this, it's easy. We assume that its density inside is uniform, that there aren't big lumps of material on one side to tip it over, because it balances in the middle. And actually, to get the centre of gravity, we have to balance it in all three directions. Okay, this is easy. This is the most stable, most easy. You can, in theory, do it with this as well, this direction, and it won't tip towards or back. And you can do it like this. And where those three planes or those lines would cross, that's where the centre of gravity is. Yeah? Does that make sense? Easy. Not rigid. Floppy. Okay? Floppy object. So actually, its centre of gravity changes.
What are you doing to him?
Crushing him up. Somewhere in the middle. Somewhere in the middle. In the middle? Well, probably somewhere in his belly, halfway through, about here, like in a human being when they're standing up. Okay. So what good does this centre of gravity do? Bless you. What good does it do? Well, it has actually got something to do with what? Yeah, answer.
Balance.
It is to do with balance, yeah, and it can also be to do with forward as well. Okay, if he is going to balance, then his centre of gravity has got to be above a stable area. Okay, or it's got to be in contact, or above an area of contact of his body with the ground that is stable. Okay, here, he's not stable at his legs, so he's actually never going to stand up because his centre of gravity in there is going to tip him forward or back. Now, luckily, we don't do that because we've got muscles that don't tip us over. Otherwise, we would, muscles and bones. Yeah, if it's just the bones, wouldn't work.
And if it's just the muscle, it wouldn't work as well, I guess.
Okay, fair point, fair point.
Uh-huh.
Okay, so the falling bit, yeah? Yes, when he falls, his centre of gravity follows a straight line. The rest of him might spin around, but his centre of gravity drops straight down. The centre of gravity is the imaginary point at which the weight can be said to act. All of his weight.
Cool.
Same with us. All of our weight can be said in physics, in simple dynamics, in simple models, to act about halfway up our body, and it's got the weight of our total arms, head, etc., etc. So about this high, 90 kilos, 85 kilos, whatever it is, that's me. And instead of actually looking at the way my whole body moves, if I wanted to work out the energy needed to jump up, I'd work out the height I jump and the height my centre of gravity would jump up. Is this making sense? No. Yes? Sort of. If I want to do a step workout at the gym, step aerobics, yeah?
Step up.
Step ups. I am lifting my feet maybe that high, yeah?
Yes.
I'm lifting my centre of gravity that high. So I step up. So actually it's like lifting a weight equivalent to me that high. Could you do that? Could you lift your own body weight that high with your arms?
Yes.
How many of you can lift your own body weight?
Me.
I'm
I can
pretty
even
weak, so
I can
most
lift
likely
Okay,
not.
excellent.
bench press.
Excellent. Now our bodies actually do that naturally. When we step up, well, you've all done it. You've all climbed the stairs. You've raised your centre of gravity from a little bit above the ground to where it is now. Ourselves.
I got a question. Does it count like so if I can like in the gym, if I can like bench press like maybe 55 or 60, does it mean I can do the same thing with bicycles?
No.
Because it's a smaller muscle. Yeah, a weaker one.
Yeah, but when you bench press, you're using more muscles. You're using a different combination of muscles.
But it works out. Not
Yeah, but you're using a different variety of muscles. So, yeah.
And it's true that you can't use the same amount that you use for your legs. You can't use that.
Yeah. If you think about it, when we are lifting our own body weight, when we are climbing, this is why climbing stairs is so exhausting compared to walking on the flat. When we are changing the height of our centre of gravity, you are not used to doing that with your arms, unless you walk up the stairs on your hands. Yeah.
What was my question?
I don't know. Let's.
Yes. Is it normal that I can lift more with my back than with my legs? Because I can lift 75 back, but
Oh my
not
God,
75 with my
Netflix.
legs. No, maybe 75 with my legs, but
I don't know.
I lift a lot.
My favorite.
Okay.
Come get back.
Now the high jump. Running along and did I show you this last time?
No.
Running along and jumping over a barrier.
Was that a kangaroo?
Was that what?
I think there's a picture of a kangaroo high jumping.
Really? Wow,
I'm
clever
not sure.
kangaroo. Okay. So the scissors technique.
Beautiful.
Beautiful. Does the person who did the scissors technique hold the world record, do you think? No.
It'd be pretty cool with
Now we do the flip.
Now you do the flip, don't you? Otherwise known as the Fosbury flop, after a Mr. Richard Fosbury, who was the first person to do it.
Ooh, he's tall now.
He's very tall, yeah, not quite so tall. So, how did that enable the world record to suddenly change style? Lowry.
You don't have to lift your center of gravity so high.
You don't have to lift your centre of gravity so high. Well done. You were going to say that, weren't you? His centre of gravity, see a colour that is there inside his body, not on his leg. Yeah? Because if you were to freeze that person, I don't even know if it's a man or a woman, you were to freeze that person, like outside in the cold, dead, solid object, yeah? And then you were to balance them, like I did with the ruler, that would be one way to find the centre of gravity. You'd find where they balanced. So if you were to pivot them on their back, it would be somewhere along there. If you were to pivot them, oh, that would be painful there. Okay, where those lines meet, that's where the centre of gravity is. Do you get that idea? Yeah, okay. Centre of gravity of this person, oh, okay, well the legs are here, head's up there. Let's say it's here. It's actually in a slightly different position because of the arch of the body. The centre of gravity is that far above the beam, that far above the beam. So if you can raise, if this person has got the energy to move their centre of gravity that high above wherever the ground is, yeah, the bar is here. So that's maybe, I don't know, 20 centimetres short of where the centre of gravity is. Whereas here, it's only a few centimetres short. So it allows you to raise the bar higher so the record goes up. Clever. Yeah? No, not clever, Esa. Yeah, clever. It'd be very, very impressive. So, same with the pole vault as well. I mean, that style's quite a difficult style to use. When you learn to do the high jump, you tend to do the scissors jump. It's all to do with the centre of gravity. Okay. The triple jump.
What the?
Oh,
Hop, skip and jump.
Oh,
Hop, skip and jump. Yeah? Do you do the triple jump, Heather?
I don't know what it is.
You don't know what the triple jump is? Okay.
I think we
This is a lesson in ancient history.
The one like,
Hush! This one.
Here's Jonathan in the first round. Oh, it's huge, it's massive.
he's
My
flying.
goodness, that is fantastic and it's legal. Here's Jonathan in the first round. Oh, it's huge, it's massive. My goodness, that is fantastic and it's legal. 1.3 meters per second. 8 meters 16. It's legal with 30 feet in a long jump. 80 feet in shot putting. It's such an exciting sport. 18 meters is one of the greatest ever in triple jumping. It equates with 30 feet in a long jump, 80 feet in shot putting, and goodness knows what for a mile. Oh my goodness gracious me, the first round. Oh, it's huge. It's
Okay. 1995, well before you were born. And he smashed the triple jump record twice in one night. How do you suddenly do that? How do you make such a big advance in your sport? Because I think he was half a metre longer than anybody else had jumped before.
steroids.
I was gonna say the
Long
same.
legs.
Long legs, yeah. Of course, the suspicion is steroids. Now, 1995, it wasn't such a huge issue, but of course he would have been drug tested for it. Not long legs. He's not that tall. Artsel?
All about the technique.
Yeah. It's all about the physics.
Yeah.
What's he done? He has launched himself. This is the bar. He's set himself off, and he has jumped further than anybody else. Okay. Now, to get to that level, right, his center of gravity has to go the furthest along the ground. Now, you know, when you throw a ball, if you throw a ball straight up, it comes back down there. If you throw a ball horizontally, it goes like that. What angle do you have to throw it at to get the furthest? Do you know? Does anybody actually know the angle to get the furthest distance? Arcel?
You mean the
You want to throw it high, the highest, you throw it straight up.
in between horizontal and high?
Yeah, which is
Arc, I guess.
45 degrees.
Okay.
Okay. Now, what Jonathan Edwards' team did was they filmed him doing lots and lots of triple jumps. And you've got the hop, the skip, the jump. So you've actually got 3 different movements. And as he was doing his running, they did computer simulations there. He's doing a mad dance running. And they said, okay, your center of gravity is here. And they plotted out where, not his body, but his center of gravity could be. They made a prediction about the angle that was needed from the hop, skip, jump combination. And I think it was something like, if you take off a little bit steeper from the hop, you can jump further. And at one stage of his jumping, they actually changed the angle he was taking off at by about 3 degrees. And that 3 degrees translated into an extra 0.5 meters along the ground. Does that make sense?
Yes.
Yeah. And he could repeat it. He was the first person to do it. Then all the other triple jumpers got in on the act. What on earth has he done? And it was a matter of analysing the film footage of it, plotting out the centre of gravity and the physics of it, and then saying, okay, let's get everybody doing it. Now the triple jump is standard for those distances. Sports science, serious stuff. Yeah.
So do you like athletes really need to know about like all this stuff to
Yes.
like get this?
If you are looking at the top performances, because there's a load of money that goes to the medal winners in very, very many sports, like in athletics. If you're actually going to look at why Usain Bolt is so fast, what is it about his muscles? What is it about Kenyan, Ethiopian runners that makes them into such fantastic long distance runners, particularly when most of them start off barefoot running? Okay, then the sports scientists get very, very excited about all of this. Very excited. All basic physics. When a record gets broken, yes, of course, there's a lot of suspicion about it, but there has to be some sort of explanation. Why did it happen? The fact that he did it twice on the same night meant that he must have learned something about it. Okay, now in the Beijing Olympics, a lot of swimming records got broken because there was a new swimming costume that was being used, a new fabric, and it was taking 1,000th of a second off the record times, and that was to do with the low friction of that costume. Okay, the javelin record. I can't remember what it's called. Finns are very, very good at javelin in general. The javelin record has actually had to be deliberately reduced because the materials that javelins could be made of now, if someone throws a javelin from one end of the stadium, it could actually hit the crowd because of the design of the javelin. So the design of what you are able to use, your costume, maybe your skis, the shot, the discus, the javelin, that has to be very carefully controlled. Yes?
Even though Finns are like really good at javelin, even in my opinion, but there's like been a accident. I'm not sure which year it was, but yeah, it was kind of scary.
Definitely.
It was not a death because of a javelin, but it was a serious injury because of the javelin, and it was thrown by a Finn. But also it was kind of.
What, did it go too far?
No,
and
it
hurt
was
some?
just because the organizers had put the long
Google
jump
this.
extremely near to the javelin place, and then something happened.
Yeah. It's similar with the pole vault. Poles can.
Oh, some people sprint so far they die. Yes.
Oh, okay. Actually, that's long jump record progression, not pole vault. But again, something's happened with the long jump. Huge change here. So the material, maybe the springboard or something like that, has been changed. Let's have a look for the pole vault. I can get it. Men's pole vault record. Oh, look, it's in a maths page. Excellent.
Maths and you.
Maths and you, yeah. Let's see if I can copy that.
Boy.
Voy voy. Okay. Here's a sudden change. Then it laid flat, actually. Maybe the wars stopped progression. But here, I think, was when the aluminium pole came in. I think it was wooden poles before then. And now here there was another change in the 80s.
I can't the wooden pole like crack.
Yeah. Dangerous sport. Like javelin. You might get something thrown at you with the javelin. Interestingly, I believe there is no restriction on the size of a tennis racket.
What?
Tennis bat.
So I can have a really big one.
Yeah. But that then is heavier. So
Yeah.
you can't swing it so much. But when you do manage
What if
to
I
swing
would have a large one and then I'd be like,
Yeah, yeah. There is, however, a restriction on the tennis balls. Tennis balls have to be very, very carefully controlled, but not tennis rackets. And gradually, as sports get more scientific, these rules do change. Henry.
So if you have a tennis racket, the size of like your whole like area of like space to move,
Yeah.
and each time the opponent like shoot their like the
Bounces off.
the tennis ball, it's just like it's anyways because if the tennis racket is like as big as like
No, but
Yes, you mean having tennis on a trampoline, sort of thing. How could you move with it if it were?
no, but if it were to be like basically your whole like the whole like place that you can move in.
Yeah.
yeah, but you wouldn't move it at all.
You just put it there and
And
then it's
watch.
How would
No.
you serve?
There's actually no use because you hit the point.
throw it
Your
against
opponent gives like the start as hard as he can. It touches your racket, goes off
I think
your
you've
racket.
invented a whole new sport. Okay,
We'll never
Right.
use this court.
enough chatting about it.
Off yours and get out.
So, what did we write last time?
Balance.
Balance
Equilibrium.
and falling over.
And center of mass.
Centre of mass, yeah. Okay, so just going to give you a few notes. I've got two other things to get onto this lesson. They're not very exciting. I do apologise for that. It's a bit of a catch-up lesson. More excitement next week. Sorry. So, this is
I'll do
How does like this?
Types of equilibrium or balance.
Oh,
it.
So an object
No. No. What would you have?
is unstable, Horriba, or however it is
Rather
pronounced,
horrible.
Horriba, if its center of gravity falls when it moves. So something is unstable if when you move it, its center of gravity will fall. Really, really easy example. We have a hill and we have a ball on the hill. There is its center of gravity, and it will lower if it drops, e.g. ball on hill. And there are two other types. Would anyone like to hazard a guess as to the next type? What we might call it, given that one is called unstable. Yeah,
Obviously stable.
stable. Thank you.
That was a hard guess.
And there, the center of gravity will fall back. So we've got the center of gravity. If you move the ball, it will then drop back down. Okay, the center.
Like a skateboard ramp.
Yeah,
But then at the end, it'll just stay in the middle.
Yeah.
Slow down and get friction. What you from? Oh, please.
and there is actually one more type.
Possibly stable.
Almost.
Good answer.
Yeah.
So like in basketball,
Yeah.
you need two techniques for like close shots and feather shots.
Yeah.
Yeah, because if I'm to throw like a free throw, I'll throw it up, then I'll go down. But then if I'll throw a three-pointer, I'll throw it further, so then it goes like not too high, not too low.
Yeah.
Just in the middle. If I wanted to go swoosh.
Basketball is all about the control of the centre of gravity of the basketball
Quitos, quitos.
and your centre of gravity as you are playing
Quitos,
it.
quitos. If you don't have a good like,
A b-ball. What's the B stand for?
Basketball.
if you ain't like how to say like well, how to say balance when
Yeah.
you take a shot.
Yeah.
Like you have most probably gonna have a shot which will bounce off. That's why in trainings, how do you call the weird thing that you had? The thing that you gotta balance on.
The balance board.
Yeah, we also have some trainings where we're on a balance board and then we gotta shoot from there to get more familiar if we were to be unstable.
Yeah.
And I get
There are very, very few sports where balance isn't really majorly considered.
swimming.
Well, even then, you've got to keep your centre of gravity up.
What would you say?
Synchronized swimming is absolutely astonishing with centre of gravity.
Is that the one?
Yeah.
True.
Synchronized swimming is where they're all kind of dancing underwater and
And
above
then you do
water.
flips, then you turn
It's
around.
absolutely, the
So
balance
the
control is
motion-
incredible. And then it's not a sport, but ballet.
It's a sport. It is.
Whoa, it's a sport.
I got into trouble the last time I said that about synchronized swimming. I'll never ever dare say that again in front of video. Because actually, I hadn't thought about it. Now I admit I'm in awe. I'm in awe of ballet, but ballet a sport?
It's an art form and also a sport.
I would.
I have.
Hang on. You mean you get competitive ballet?
Yeah.
You're complete.
Well, sports don't always have to be competitive.
Yeah, that's
Yeah.
true. That's true.
That's true.
Who does sports to not compete? I'm sorry, but I'm okay. Sorry.
I mean,
That's
like,
just me.
I play basketball to compete, so then I become NBA.
Yeah, as I said, he's a b-ball.
Can you can enter ballet competition? Like singing competition.
I dance to compete.
Same.
Just kidding, not only. I don't know.
It's so sad that a beautiful art form gets turned into something.
Yeah, but then
But it's
sometimes,
fun.
sometimes it's like, so that you get into a higher, like, place. For example, ABT, American Ballet Theater. Like, for example, from School of American Ballet. So it's kind of like a audition, but also a
I get to enjoy
competition. But then sometimes you go to actual ballet competitions to win money.
Money. Okay. Okay. Well, Therese, I will finish my word in a minute. Yeah.
I think it's absolutely terrible. Like, the competition is like too hard. And my brothers are like in football. They play football in a team. So it's just sad because some parents just shouted that you're bad,
wrong.
do something.
I must admit, I do find it very, very distressing that you take up a hobby here at the age of, I don't know, 3 or 4.
He's great.
You get good at it. By the age of 12, you're struggling to do all your homework. Every weekend, you're up and down Finland doing some competition. And the pressure on you is absolutely huge from coaches,
White.
parents. You wonder who's competing. Is it the parents or is it you? Yeah.
It's all the
Oh, yeah.
Yeah. Okay, neutral or intermediate? God, better word in Finnish. Okay, so what's happening there? Well, that's really bad. It's meant to be a straight line. Straight line. Okay, the centre of gravity remains on the level as the ball rolls. So, to be good at many sports, you have to be in control of your centre of gravity. Ideally, if you think of the Olympic ideals of higher, faster, stronger, you want your centre of mass or your centre of gravity not to be too large, so you want a low weight. You ideally want to not have to lift it very high off the ground, because the higher you lift it, the more energy it takes, the stronger your muscles have got to be.
Look at my dad.
And your balance sense, your innate balance, which you can train, should be very good, so that it doesn't topple over. So somebody like, I think I might have to be a little bit careful and freeze this. I don't know what is going to come up on the search. Tom Daly.
Oh, a cute little British swimmer.
Cute little British swimmer.
Oh, he's so cute.
Okay. So, his centre of gravity just falls straight down.
91 points this morning with this.
His arc is twisting and turning around his centre of gravity. He can't stop his whole body falling. He can't stop his centre of gravity from falling. But what he's trying to do is twist and spin as much as he possibly can around that falling centre of gravity.
I can do the first thing on the trampoline for 0.6 seconds. Then the flip of the
Why did you have to freeze it away from us?
Oh, because he's had all sorts of fuss in the British press recently about cheating on his boyfriend.
Oh.
Oh God.
Oh, we're
And he is-
engaged.
Yeah.
Yeah.
Right, 3 minute stretch break. Go and move your centre of gravity.
That's like this. Look. No, he doesn't do like this. He does like this. No, it's just like, no, wait, it's like this. No, it's like this. It goes like this.
Your centres of gravity haven't been raised.
Now it has.
If I do it well, I do this.
And naturally, it's gonna lower itself.
Yeah, it will.
Because of gravity pulling down.
Come on, how many of you can touch your toes?
Not me. Wait.
You do it.
Greatest.
So can I.
Good.
Damn. I'm gonna try to put my hand on it. Let me try.
Tietysti voi olla paremmin, mutta ei internet-rekona ärsyttävä. Niin se on tärkeää. Niin Grace-Anatomy siis miettii, niin mä mietin tätä internet-rekonia vaikka Sparkilta Ice-Jumpin, koska mä en tarvitse sunkaan. Mut mä en tarvitse Ice-Jumpia missään tekissä tai tälleen.
Yeah, but still a lot older than you.
Ai 110 itse Miten syöksä muita?
And before playing,
Right,
OG Production. OG Production. OG Production. OG Production.
Wait, hold up. Let me do it. Let's do a handshake with this one. Yeah.
Okay.
If I score, then I whack.
The next topic we have to deal with, I have to explain to you. Yeah.
I love writing notes.
You love making notes.
It's so naturally so.
That's what we call chronological.
Motivating.
No, fun.
Notes are
When
fun.
you make them look good, it's so much fun. My English notebook is my favorite
Are
thing.
you saying that you'd rather sit and do hours of notes in my lessons?
No, probably not.
Like, you
But
can have
like,
a
I
clock,
love
you
writing
like a
notes.
clock, please. Are you good?
I have a notebook full of notes for tests.
I'm not a clock. I'm deep.
I love doing notes.
Have you heard, this is a diversion, have you heard of bullet journaling?
Yeah.
No.
Have you got one?
Yeah.
Would you like to explain what a bullet journal is?
For sure. I saw him. Yeah.
It's quite funny when you all turn on it. Yeah, go on.
It's kind of like a mix of calendar and diary that you put there, like, at least I do it like that. I put like tasks, which I need to do on that day, and then I cross them over when I have
I would love that.
I've just started one and I'm thinking that they're actually really good and I wonder if they'd be really useful for you time management wise. Yeah.
So smart.
calendar with space to write.
You start off with like a notebook.
Yeah.
So the people who are serious about it actually get a notebook with dotted paper
Yeah,
in.
my friend has one of those.
Yeah, I must admit mine's got dotted paper in it. And in it you mark out like you've seen the teachers' diaries, haven't you? With the lesson plans in things. And everybody uses theirs with a different style. And Tanya is very famous for having hers coloured in, which is great. So I now have a colour for grade 7, colour for grade 8, colour for grade 9. But with the bullet journal, you design it how you want it to be. So it's like having your notes and taking pride in them. And this, I think, is something that is being lost because we're doing so much electronically. And the whole idea of taking notes is really amazing.
Oh,
The process. So
I love just watching people write down notes.
why don't you maybe do something like that? Okay, here's somebody's saving goals. That's what they've decided to do. Books to read, Sunday, Monday. And it's really, really motivating. And for something like study or a personal project when you're going to have to do that, that's really good. Okay, this is really, really simple. It's somebody's blog schedule. But like, I've got one of these going for March. Okay, it hasn't got the same categories, but
Meditation.
yeah. I monitor like my Meniere's symptoms. I've been doing that. And green means it was a good day. Orange, not so bad. Red, a bad day. And it's really visual. It's really easy. And it's not something on a computer screen. You're saying you like taking notes. You like writing things down. You might want to look at this. Okay, it seems to be one of the latest fashions, but actually, I'm thinking it's really, really good. You can also include in it things like study schedules, revision schedules, time management. A few years ago, I had a group of grade 9s who were absolute perfectionists, and I was trying to get them to monitor how many hours they spent at school, doing homework, doing hobbies, online. Were they multitasking? Were they doing their study and being online? And how much time was sleeping? And doing that over a whole week is actually quite interesting. You may say, okay, I don't spend a lot of time online, but if all the time you're doing your homework for 2 hours, you are also WhatsApping, etc., etc.
I watch Netflix when I study. I know that's a bad thing, but I need to have something else.
Some people say actually they need that.
It is
I need
nice.
Well,
some kind of noise in the background.
Yeah, but do you do you need it to help you focus, genuinely multitasking, or how much of it is distracting? It's really
I reward myself every time I get something finished. I can watch 5 minutes.
Valtteri?
I know I'm like regretting it that like I started playing video games on PC because now I'm extremely distracted like every time I do my projects.
Yeah. When does it become when does it become not useful? And something like a bullet journal could help with that. So for instance, I'm trying to get offline by 7:30 every night. I'm trying not to look at a screen up close. TV's okay, but to get off it, to try and help my sleep better, to help my sleep improve. Anyway, back to physics. I recommend bullet journaling though. It's very therapeutic, it's very soothing. It's like building up a good set of notes. Pressure. Now, this is something you experience a lot as students, but it has a physics meaning. Paine.
Pressure is a
Related to paine. Yeah.
There's a skateboard trick called pressure flip, because you put pressure on the back of the board and then it does it.
What is pressure?
Pressure is fine. It does when you put some weight on something. That's called
Pressure occurs, it happens, when a force acts on an object.
So this is pressure.
Yeah.
Yay!
You're putting pressure on your pencils as you are writing.
Oh, pressure.
So, force.
Yo, mama.
Objects. And then pressure is transmitted through that object. And that object has an area.
I got a question.
Yep.
What's a turbulence in a plane when the plane just messes up? Is that air pressure?
Yeah, which I'll talk about in a bit.
Oh, I was asking what does it like?
I'll talk about that in a minute. Remind me in a minute when we talk about air pressure. Okay, so force and
one-on-one
area. So at the moment, I am stood on 2 legs. My weight is acting through the area of my feet.
So you
I double the pressure
on the floor.
Yes. By standing on one leg, because I've halved the area. I'm not going to do it, bless you, because I'll fall over. But if you change the area of your foot to be your toe tip, and you stand on tiptoe, there is a much higher pressure on the floor. So for instance, if the area of my feet on tiptoe is like 1/10 of the area of my feet or 1/50 of the area of my feet, then I've got 1/50 of the pressure going into or going across the floor. So if I was walking across snow on tiptoe, I'd sink. If I increase my area by having big shoes, I don't sink. Does that make sense? Yeah. Okay. All to do with the distribution of pressure. Okay. So, and that is usually the way that we teach about pressure. Okay. Small area, large pressure. Big area, small pressure. So, large snowshoes don't sink as they spread out the force equals weight here. I hope that makes sense. Sometimes it can work the other way around. Like you sit on a thumbtack, you sit on a pin. Ouch. You've got a very small area, the pin head, the needle, the sharp nail part of it. You sit on a thumbtack, you sit on a pin. And your weight goes over that small area. So there's a very, very large pressure and it hurts. Big time. Okay, there is an equation that you need to be aware of. Pressure equals force divided by area. Or you could write it F over A, or you can write it F divided by A. Whatever type of divide sign you wish to use, it's the same.
P equals
and
shut up.
The unit, what it's measured in, is the Newton per square meter.
Today wasn't good. I can make that. Johnson. God damn, I'm that reset.
Or the Pascal.
Pascal. What's Pascal?
PA, after Monsieur Pascal.
Frenchman.
Of course, yes, yes.
Pascal, Pascal.
And this now is where pressure gets really, really, really confusing, because it is used as it's in very, very many different contexts with lots of different ways of measuring it. You just need to be aware of it. Now, everyday pressures. Number one, as Artsel's mentioned it, air pressure. Now, air pressure is majorly important. Our weather is caused by air pressure. Air pressure is caused by temperature. Air pressure in outside an aeroplane, when the captain says, please put your safety belts on, there's going to be turbulence, it means that the aeroplane is flying into an area of different air pressure.
Isn't it often when you go through like a storm?
Yeah, storms, etc., etc. And it means that the aeroplane can actually just fall because the pressure is low. And you are like riding over waves. It's like, hang on a minute, it's like being on a boat and going over waves. That is how air pressure can be. Arcel,
when there's turbulences, I feel sick. My belly goes up, down,
Yeah.
up.
Yeah.
I often sleep
Yeah.
through them.
It's messed up.
I don't think there has ever been an accident because of like turbulences.
Yeah, they have. Yeah, they have. It's very, very, very rare, and you'd have to fly into a storm cloud. But for instance, the turbulence that you would feel if you went into a hurricane would be pretty awful. Now, let's have a look at our air pressure at the moment. We're ever so slightly lower than normal, I think. One of my favourite websites at the moment, because I am such a nerd.
Yeah, it sure looks very.
It is. This is air pressure.
That's ugly.
Right. Dark purple is low pressure. This is kind of average pressure. Red is high. So, yeah.
So if there would be turbulence, would you want there to be less pressure or?
When you are flying into turbulence, it usually means that you're flying into an area of low pressure. And this is air pressure at ground level. It varies even more as you go 10, 11 kilometers up. There's much, much lower pressures. So what is usually happening is that the winds have created a little pocket of low pressure, and you're flying into that, usually where the clouds are. Because where you've got clouds, you've got a lot of water vapor, you've got a lot of particles, and then there might be a gap in the cloud. And when you fly into that gap in the cloud, the pressure suddenly drops. So as you're going through the cloud cover, that's when you get turbulence. You don't get turbulence so much when you're much, much higher up above the cloud base. Make sense? Yeah, and again, it's number of particles in the place.
He's winking at me.
Okay, try and ignore looking at him.
I
He
have
can
some dust
wink
in
to
my eye.
himself.
You don't have any dust.
I do.
Now, if we go global,
Oh, that looks so cool.
it is amazing, isn't it?
You look sick.
This is somebody set this website up using Google Maps and plotting data of weather because he wanted to know the winds for sailing. And this now is an amazing indication of how the weather patterns will change. This is the air pressure map of the planet at the moment. Sit down, Artsel. Just wait a minute. I want to try and talk. So, we've got a very low pressure storm over the Atlantic, another little low pressure storm. You can see the wind direction. We've got low pressure we've got two low pressure regions over the Arctic. The southern hemisphere, does it show it as well? Low pressure again over the Arctic. Over the Antarctic. It's colder down there. The movement of air will actually go from high to low pressure. So there will be a gradual movement up towards the North Pole, down towards the South Pole. And then you've got the equator where there is normal. What is it? Yes.
That looks like an acid trip color.
Thank you for sharing. I hope if you were having an acid trip, you'd have far, far more
You'll
colours.
see all kinds of nice
There's
colors.
no pink. Can we get on?
Yes, let's talk about drugs.
That was so funny.
Because we Right.
don't like
Yeah, you
drugs.
can actually stop it.
Well,
I don't use drugs.
I whispered laughing. It's so horrible.
Like
the equator tends to have higher pressures. Okay, what's driving these? Well, they're different over the sea areas to the land areas because when the sun shines on the land, it shines on the sea, it heats them up at different rates. As it heats them up at different rates with different speeds, then the air above rises and then it moves because the air pressure will move from high to low pressure. Low pressure regions tend to be very windy, changeable weather, etc., etc. And in fact, it's not very fast, but here the little slider's going along, and you can see how the weather is predicted to change. So we're going to go into a lower pressure area, be more unsettled. Now it's getting higher again, so probably it's going to get colder during the week. Yeah, Tuesday we're at, tomorrow getting higher and higher. We're probably going to get some settled cold weather.
Tomorrow.
I'm not happy.
Wednesday, pressure's getting higher again.
Is the yellow hot or cold?
The yellow is higher air pressure.
Oh.
Okay, this will relate to another map where we are looking at temperature. Okay, this is the temperature map. The temperature relates to the pressure though.
Oh, that's
Okay, so we're getting colder. That is 0, -10.
It's even from the website.
What?
It's from the same website. It's beautiful.
Yeah, it is. This is temperature.
I do like this.
Temperature is beautiful, even though you can't
That's
actually
result.
see it.
So what did you
Right, this at the moment is indicating temperature. The lighter blue, the colder it is.
No.
Why does
Now it's getting warmer again Sunday,
No.
and it's hovering around freezing.
It's always freezing if it's less than 5 degrees. Like
This is
5.
just a prediction,
Well, it's not gonna happen.
okay? Just predictions. And the temperatures are predicted from the air pressure movement. Okay,
Is purple like absolute?
that
Yeah.
purple is -20.
Huh.
Purpley red is -20, whereas this
This is the warm
is
country.
up to 40.
Yes, I'm going to Congo Democratic in 2
When?
days anyways.
When are you leaving?
I can leave whenever I want.
I'll give you the website if you ever want to look at it.
I
It's
gotta go home, I
Windy
gotta pick him.
indie.tv. It's very, very good.
I gotta pick that good song in. So then you can always do the night.
Now, you look on the weather forecast, and the air pressure is given units of MBAR, millibars.
What? I would like to go to that.
Okay, and got to check on my phone because I always remember the wrong number of zeros.
Mine
Okay.
is Swahili. Yeah, can't. No.
1,000 millibars is approximately
Where do you see? I see cancer.
normal air pressure at sea level. Now, why do we have an air
What do you
pressure?
think?
We don't actually usually notice it unless our balance mechanism is messed up. We might notice it in an aeroplane. Our ears might pop. You might, as you are going down a mountain slope
Yep.
or into a tunnel,
Yep.
yeah, that's water pressure though. Same thing though. There is something that is outside of our head that is creating a different pressure. It could be water, but if you're in an aeroplane, you're going through a tunnel, you're going down a mountain very fast, then you notice that there is something different about the air. It affects what's inside your ears. We don't realise, but above our heads, we have got tens of thousands of kilos of air. Okay?
Oh.
On every square meter
Everything.
of Earth's surface there is let's get it right 10,000 kilos of air. 100,000 newtons. That normally surprises people. Your desk, your partner's desk, is about a square meter. So above that area here, where you'll start writing, someone has piled up 10,000 kilos of air.
Okay.
A litre of bottle of soda has got a weight of about a kilo.
Yeah.
So imagine 10,000 of those on top of that desk. It's there naturally. The air has a weight, it has a mass. Gravity pulls it down. We don't notice it, yeah.
So about how many kilos of air is there like in this room?
In this room, well, in the room or above the room. Like the whole atmosphere.
No, like in the room.
In the room. Very, very, very good question.
I'm trying to get home.
I'd say it's less than a kilo. Air doesn't weigh very much.
What's wrong with rubber?
So there's a lot of air.
I have no problem.
There's 11, 12, 15 kilometers above us.
That's what I heard.
What?
He has no stomach, he has a six-pack.
Different things.
Yeah.
I think we know what he means. I shall resist making jokes about pooping. So, that air, sometimes when there's low pressure, there aren't so many kilos. Sometimes when there's high pressure, there are more kilos. If we went to another planet, the air pressure would be different. We go to the moon, where there is no air pressure, then actually our bodies aren't designed to live like that. Yeah.
The moon is not a planet.
Yeah.
Sure. You know what I mean. If we go out into space, if we could just be blasted into space, there is a lot of debate about what would happen to us if we had no spacesuit. If you could just be placed in space, you would be crushed, you say.
No.
Is there pressure pushing down on you to crush you? Or is it what's inside you pushing out? Yeah, Henry?
And also, like, I don't think you get crushed, but a lot of people think that your body explodes, but like, because the water inside you, inside of your body begins to like, I think it was like evaporate or something. I can't remember what it was. And then your body begins to like swell up, I think, or something like that. I can't remember.
Right. There's a lot of curiosity about it. No, you wouldn't explode.
Can we test it?
I'd love to. I'd love to send a few people out there.
I can go.
I think our
Now.
How to become beautiful.
If you open your mouth, the air that's in your lungs is going to rush out. Okay, now a lot of people originally said, oh, you just explode. Well, actually, no, our bodies are quite strong. Our skin, our muscle, even our eyeballs, they could cope with the pressure difference. How do we know? Well, unfortunately, one of the things that the Nazis did was lots of experiments. They put people into vacuum chambers, they began taking the air out, and they monitored them.
Yes.
Quiet,
No,
please,
yes.
enough. Put your hand down. Thank you. And that's a bit different because they took the pressure down gradually. If you could be taken into space and then just left in a vacuum, it would be a bit different. Yes, anything loose inside your body that isn't held in by a continuous layer, like anything that could get out of your ears, your nose, your mouth,
Like what?
your waist holes, that would
Oh.
come out.
You.
Okay?
Yeah.
Because it's very low pressure out there, any gases would start to evaporate and you would have a problem with the gases in your blood. A bit like when a diver comes up from a very, very low depth where there is high pressure, the gases inside their blood can boil out too rapidly and they get the bends. So you've got to be very careful when you come up from a very low pressure. You undoubtedly will die out in space, but it will probably be quite a slower death than most people predict. You are probably going to have lots of brain hemorrhages and things like that from your blood boiling away and stuff like that. Not very nice.
Can I ask you an honest question?
What?
Can I ask you an honest question about like astronauts?
Yeah.
Where do they go to the bathroom?
In
They
their
go to the
bathroom.
bathroom.
They have a bathroom.
They go to the
NASA has
bathroom,
actually
like-
designed a vacuum, but it works without gravity.
No.
Yeah.
Can we?
Sorry,
Yeah. No, it's a very, very important thing. How do you pee and poop in space? But we will talk about zero gravity later on. But they have facilities. Otherwise, it's a very long wait. Some people are up there for a year. Yeah. But you can't just pee. You have to go into the peeing machine. Okay. So, blood pressure.
Oh.
That's how I do.
Is it number 2?
Yeah, number 2, blood pressure. Okay. Does anybody know their blood pressure?
Mine is good.
21.
Mine is
God.
50.
I did it check so many
Percent.
times a year, but I
I've got something slash something.
I feel like 25% blood pressure.
I've got to look up a normal blood pressure. I have got no idea what a normal one
I have
is.
a no blood.
It was funny too.
Well, to me,
I'm not sure about this one, but I think like a year ago I was
do you know which type of blood pressure it was?
Why? I was
Right. Right. And it's quoted as 120/80 to 140/90 is normal. Thank you. I just want to get rid of that. There. Now, those units, that 120/80 is measured in something called millimeters of mercury. So it's a very, very weird unit. It does equate to pascals or newtons per square meter. You've got 2 numbers because your heart has got 2 ways of pumping. It pumps one set of blood to your lungs and one set of blood around your body. It's like 2 pumps. And to go to your lungs takes less pressure than to take the blood all around your body. So that pressure, 120 millimeters of mercury, that would be a lowish blood pressure. 140 would be high, and your blood pressure should be between those. What does it mean? It means that if somebody sliced your artery, someone came along and slit my throat right now.
Oh, you die.
Yeah, but before I died, I'd splatter you all with my blood.
Oh, delicious.
So that amount of pressure, if you think of the pressure in a water pistol, how far it will fire, probably won't reach Art Cell and the back row, but the rest of you could get covered.
Arsel's gonna be left out. Is that
Yeah.
fair?
No.
If my blood pressure were higher, it would go further.
It would be delicious.
What, are we delicious?
No.
You get it bad, but nothing's delicious.
So,
What? Nothing. That was a really dumb question. I was
we
about
didn't
to
even
ask.
ask it. Only the first spurt would go very far, and then gradually, as the blood got less, yeah. Now, why millimeters of mercury? Because you used to be able to measure blood pressure using, and actually atmospheric pressure, using a big column of mercury, which of course now, like in thermometers, it could also measure air pressure, but that now is of course banned because you can't measure things with mercury. But the unit, the old unit, has stuck. There is another unit when you're measuring air pressure in cars, the PSI, pounds per square inch, or you might measure it in pascals. I ought to set you some homework, shouldn't I?
Actually, yes, you should.
Actually, I'd like some homework.
You'd like some homework.
I'm sorry, I'm in a really weird mood.
Yes, extra homework. We never have it. Lots of homework. I don't
Oh,
want to
until Thursday.
Oh, yeah.
Look at me. I guess.
What are you doing?
Sorry.
Are you for real?
The only effect is what you were doing. And I don't. The only solution is a resolution.
Are you kidding me? My bike just got
No, no, no.
stolen. Oh, I know this one.
No, I don't. Okay.
About 70 psi.
Okay.
Eat the louder. Or maybe 2 to 4 bars.
Actually,
It depends what kind of bike you get.
yeah, bike tyres, car tyres.
Yeah, I'm gonna measure that one.
So look it up. Don't care if your bike got stolen. It had tyres on it. You should have done it beforehand.
What? No, but it depends.
I have no bike.
It does.
I know
Like,
black ties.
I know. Jimmy Turner, rolling with my
there's like normal bikes they go like around 2.5, I think, or something like 2, 3 bars. Then like if you got like a racing bike or like one of those, it's usually like 6.5.
Yeah.
You don't know how to count.
Right, guys. Okay.
What a shame. You seem very unhappy.
Yeah, really unhappy.